All right, so this is our notes for 2.2, and we're talking about the graphs of functions. So for every function, remember, a function is different from a relation, right? A function requires a certain criteria. So for every function, for any function, there is only one y value. Y value for every x in its domain. So basically, every x that you put in, you only get one single y value. You cannot get a duplicate, right? You can't get two different values for y. Um, and a graph represents a function. So when we're looking at a graph, it represents a function if it passes the vertical line test. And this is something that we did in Algebra 2, but I'm not sure how Algebra 2 went last year. So we're going to do that again. So let's look at these graphs, okay? And we're going to use the vertical line test to see if it's actually a function, okay? A graph of a function. So vertical line test is, you just imagine there is a vertical line, right? And then you move it sideways, back and forth. And so you imagine putting a pencil down on your graph and you just move it left and right, left and right. And you want to look to see if is there any point where your vertical line touches your graph at two different spots, right? So for my this first graph here, doesn't matter where my line is, it's only going to touch the graph at one point. And so this is a function. It passes the vertical line test. Same thing here, if I put a line anywhere, or if I move my pencil left and right, doesn't matter where I go, it's only going to touch the graph at one single point at a time. Okay, so again, this passes the vertical line test, so it is, yes, a function. For part C, if I put my vertical line right here, you can see that it's illustrated here. It touches at two different spots. If I move it here, it also touches at two different spots, right? It only needs to happen once for it to fail. So this one fails. So this is not a function, right? This is not a function. Same thing here. I see this line, the vertical line, touches the graph at two different spots. So this is also not a function. Okay, that's how you use the vertical line test to see if the graph represents a function. Okay, for every function f, then the point x and f of x is on the graph, right? So these are the points on the graph. Remember, um, your point, the first one is the x value and the second one is the y value, or represented by f of x. Okay, all these points are on the graph. So if they give you this point here and they say that it's on the graph, then you know the f of, so remember, this is your x and this is your y. Okay, so this is -3. F of -3 gives you 7 as the result. Let's look at example 1 here. So I got f of x is equal to -3x squared plus 5x. Remember, the number that goes in here is the x, and whatever the y is the right portion. Okay, so I have f of -1. Is it equal to 2? Okay, is it equal to 2? That's what they're saying. So I put -1 in for x, so -3 times -1 squared plus 5 times -1. And -1 squared is just 1, so I have -3 minus 5. Is it equal to 2? And that's a no. Okay, so if you want to check if a point is on the graph, you put the x in for x, and then you solve it to see if it's equal to the y value. Okay, and it's not equal to 2. So not equal to 2. So that's not on the graph. Now they want you to find f of 5. So f of 5 is equal to, so you put 5 in for x, right? -3 times 5 squared plus 5 times 5. Again, they're just looking for this point here. If they say f of 5, meaning 5 is the x, and they're looking for this, right? Because f of 5 is the y. They're looking for the y when x is 5. And so this gives you negative 3 times 25 plus 25, which is negative 75, plus 25, which is negative 50. So y is equal to negative 50, basically, when x is 5. So it goes in for this point, 5, negative 50. And that's the point when x is 5. That's what they're looking for. Okay? What value of x? For what value of x does f of x equals to negative 43? So here, again, f of x is the y, so I have negative 42, and now they're looking for the x. Okay? All that means is I put this in for the y, so negative 42 is equal to, let's see, negative 3x squared plus 5x. And this problem is a little bit difficult, only because the numbers are not as nice, but the way you solve it is very simple, right? This is a quadratic, so I have to make it equal to 0 plus 42 on both sides. So I have 0 is equal to negative 3x squared plus 5x plus 42. And here you have to factor to solve for it, right? Or use the quadratic formula, or use completing the square. But I'm going to factor it. So negative 3 times 42 is 126. That's negative. And I'm looking for two numbers that multiply to be this and add to be 5, right? So I'm going to try like, 6, and what is that? 21. That's not going to work, right? Or 7 and 18. That's not going to work. I want them to add up to be 5, and I know one of them has to be negative, so the difference has to be 5. And then I move up until 9 and 14. That's the difference is 5, and it's negative, so that works out. I want positive 5, so I want the big one to be negative, like that. So because negative 9 plus 14 is equal to 5, which is what I want here, because that's the 5, right? So I factor that, negative 3x squared. This term becomes these guys over here, negative 9x and positive 14x plus 42. And then I'm going to factor those out. Factor the least or the greatest common factor. Okay. So I take out a negative 3x, which gives me x minus or plus 3 left. And then I'm going to take out 14, and I have x plus 3 left. So then I have these guys, right, this guy, and this guy as one factor. So I have negative 3x plus 14, and then x plus 3 as my factors equal to 0. So I can solve that out. Negative 3x plus 14 is equal to 0, and x plus 3 is equal to 0. And when I solve this, x is equal to 14 over 3, and x is equal to negative 3. So my points are 14, 3, negative 42, and negative 3, negative 42. And those are my two values of x, where y is negative 42. And then we move on, we look at the graph. When they give you the graph, you have to be able to identify the points. So they're looking for f of 0, meaning the x. Okay, this is x. When x is 0, right here, what is y? They're looking for that. So equals to 4. Okay, f of 3 pi over 2. Again, 3 pi over 2 is the x. So where is 3 pi over 2? Right here, right? When x is 3 pi over 2, y is 0. And f of 3 pi is the x. They're looking for the y. 3 pi is, so if you go, let's see, this is pi over 2, right? This is pi over 2, this is pi, 2 pi. Let's see, this is pi, 2 pi, 3 pi. So 3 pi is right here. Oh, it's even labeled for you. Okay, so you get -4. The domain of f, the domain, now this graph ends here and it ends here. You're looking at the domain that you have to look at um, the x values in that graph, right? So it ends here and it ends here. So the domain is from here to here. That's the domain, right? So the domain is x in between 0 and 7 halves pi. Okay, interval notation. The range of f, right? Okay, the range, the range goes from here. That's the highest point to the lowest point. And so if you do the range, you have to look at the y values. So the y values come out to be y is in between -4 and +4. Intercepts, well, if you do the x-intercepts, that means when y is 0. Y is equal to 0. When y is equal to 0, right here, look at the graph. Well, that's when x is equal to 0. When y is equal to 0, it's here, 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 and here. The 4 points on the graph when y is 0. So I'm basically saying this point, this point, this point, and this point. You see how the y is 0, y is 0, y is 0. Those are your x-intercepts. So I have 4 x-intercepts in this graph. Pi over 2, 0. 3 pi over 2, 0. 5 pi over 2, 0. And 7 pi over 2, 0. And then you do the y-intercept. Is when x is equal to 0. And when x is 0, y is here. And you should only have one y-intercept if it's a function, right? If you have two y-intercept, then it's not a function because that same x gives you two different y. So it's not a function. This one is a function, so you only have one y-intercept, which is at 0 and 4. How many times does the line y equals 2 intersect the graph? Well, y equals 2 is right here. And you try to see how many times it intersects. It's 1, 2, 3, 4. So you get 4 times. How many, or for what values of x does f of x equals -4? Okay, so when they give you this, you know that this is y, right? They're looking for this. Okay, so you look for y when y is -4, right here and right here. So you get two different x's, okay? Two different x's. Let's zoom out a little bit. So x equals pi and x equals 3 pi. See, both of these values give you -4 for y. For what values of x is f of x greater than 0? So as long as this value here is positive, that's what they're saying, greater than 0, right? Meaning that the y is being positive. So I have to, let me just get rid of all this junk here to show you what I'm talking about. All right, so for y to be positive, it has to be above the 0, right? So you're talking about this portion here, and this portion here. Okay, that's when y is positive. So my x is in between 0 and pi over 2, and then from 3 pi over 2 to 5 pi over 2. Oh, greater than 0, so that should not be an equal there. And then the last portion here, this one, is between 7 pi over 2 to 4 pi. And those are your values of x when y is positive.